start reviewing with 8.1. Kind of look at where we started the other day. Real quick, if you have all your chapter 7 stuff, if you have not given me your chapter 7 stuff, you can go ahead and get that out and get it ready. So we had the chapter 7 notes, we had chapter 7 homework, and we had chapter 7 test. So I'm looking for all of that. Notes, homework, tests. Yes.
I've turned in my chapter 7.
Yes.
Can I turn in the test and the 8?
Absolutely. Yeah, whatever you've got, whatever you still need to give me. And then Claire Jane, if you just want to hang around after class, that's fine. Okay. No, keep going. Hang on to 8. Is that what you said? Did you say? Did you give me chapter? Did you give me 8.1?
Yes, ma'am.
No, I don't want 8. That's not 7. Is that what this is?
Oh, yes, ma'am. I thought it said.
Sorry. I thought you meant 7, section 7, 8, and I couldn't remember if there were 8 sections on 7. I thought you meant lesson 7, 8, not 8.1. So sorry, that was my bad.
You all the notes for 7?
So yes, your notes, your work, and your test.
Did I already turn in my test?
I was gonna say, I think you did.
Yeah.
I've got my stuff right here to get everything.
All right. I completed the test, but I just don't feel really sure about a couple problems.
Okay, well, if you want to hang around afterward,
Okay.
you're welcome to. Okay, so we're going to do a quick little review of chapter 8, where we've been so far. Make sure we've got all of our notes filled in, see if we have any questions or anything we need to review, and check homework. So let's go ahead and take a look at starting with page 457 in your book. 457. So we talked about how if we have ratios, it's 2 quantities that are being compared within the same units. Remember, we talked about how if they're not the same units, they have to be converted. And when I say A to B, that can be written as a fraction as A over B, or I can write it with a colon with A colon B, okay? We know that the denominator of a fraction cannot be, what is the only number I cannot have in the denominator of a fraction? 0. I cannot have 0 in my denominator. And so, but I always want to make sure that I have my ratios written in what kind of form. Like if I have 6/8, what do I need to do to that? I need to simplify it. Good. I need to reduce. So think about simplifying a ratio is just like simplifying a fraction. Okay, you're doing simplest form. And when I have 2 equivalent ratios, that's called a proportion. Good. And so when I have a proportion, it's like having a fraction and a reduced fraction. Like having 6/8 is equal to 3/4. Okay, that's it. That's all it is. It is that one fraction is going to be a simplified form of the other. Okay, they are equivalent though. And we talked about when I have a proportion, and I can use cross multiplication. And when I multiply the denominator of one by the numerator of the other, and the numerator of one by the denominator of the other, that's our cross multiplication. Okay. So we said, what are our 2 groups when we cross multiply? Multiplying denominator by one, numerator of the other, numerator of one, denominator of the other. What 2 little groups do we call those? The means and extremes. Good. So I'm now on page 459. I jumped over really far. Okay. So we said when I multiply, I have means times extremes. Okay. And so that's what we see on page 459 in the green box, the cross product property. Now notice, let's see, the means or so the product of the extremes equals the product of the means. Okay, so it says if A over B equals C over D, then A times D equals B times C. And then number 2 on our notes, and also number 2 in the green box, is the reciprocal property. And the reciprocal property says if 2 ratios are equal, then their reciprocals are also equal. And then it says if A over B equals C over D, then B over A equals D over C. So remember, reciprocals is where I flip them, okay? So does anybody need any notes for 8.1 on your little note sheet? Do you have anything that needs to be filled out that you didn't get? Awesome. So our first assignment was page 461 through 463, 11 through 47 odds, 54 through 56. And then mixed review, page 464, numbers 69 through 73 odds. Let's go ahead and look at page 461. Page 461, on this page, we had 11 through 23 odds. Any questions on page 461? 461.
29.
Okay, hold on.
I have
Start in here.
on 39, 41.
Page 461. Hang on just a minute. Is there anything on 461? I'll take a page at a time. So numbers 11 through 23. All right, now we're going to turn to page 462.
Wait, 11 to 43?
No,
Wait, do 23?
what I was asking for is I'm trying to ask if you have questions on small sections. Instead of opening it up to the whole lesson right now, I said page 461, do you have any questions for numbers 11 through 23? I'm getting ready to turn the page and ask for questions on the next page. All right, 462. 462 started with number 25. So any questions on 25 through 47 odds?
29.
29, okay.
39 and 41.
So 29, 39, 41. Is that what y'all said?
Mhm.
Okay, so let's go ahead and take a look at number 29. Okay, so it says the perimeter of a rectangle is 84 feet. The ratio of the width to the length is 2 to 5. So I want to make sure I'm where. So this is number 29. So I know I'm talking about perimeter. What is my formula for perimeter? 2 times the length plus 2 times the width equals my perimeter. Okay, so in this situation, what did they say my perimeter is? What did they tell me in my problem, Alec?
84 feet.
84 feet. Okay, so remember, if I start with my original equation and I just start plugging in information that I know, okay, so I know that my total perimeter is 84 feet. And so I know that I'm going to have 2 widths and I'm going to have 2 lengths. Now, remember, one of the things that I've got to pay attention to is what my ratio is. They said my ratio is 2 to 5. What does that mean? When it says my ratio is 2 to 5 and I'm talking about length and width.
Is 2 and width is 5.
It does not mean that it's 2 and 5. It means that these are not my length and width. Okay, it's saying that for every 2 of one of them, I've got 5 of the other. Okay, so that's my comparison there. Let's look back for just a minute to page 458. Look at example 2. One of the things that I want you guys to get comfortable with is when you get stuck on a problem, I want you to flip back and find the sample problem that we've got in the text that shows us the example of how to do this. So if we look at the example, they said my ratio is 3 to 2. Okay, remember, I have to have one variable. So if I let my unknown be X, then when I'm talking about length and width, okay, which one do I know is going to be my longer side? Does it really, I mean, what's typically, and it doesn't really even matter since I'm dealing with all commutative properties here. But if I say my length is my longer, if I say this is width to length, okay, and my unknown is X, then that means with my length, I'm going to have 2 times 5X plus 2 times 2X equals 84 feet. Is everybody comfortable with how I figured that out? If my ratio is 2 to 5, typically I'm just going to say my width is my smaller side, my length is my longer side. I'm saying that 2 times something plus 5 times something is going to be length and width. But remember, I have 2 lengths and I have 2 widths. That's where these 2's come from. If I didn't want to do that, if I didn't want to do 2, I could have 5x plus 5x plus 2x plus 2x. If I wanted to have length plus width plus width, it's up to you, okay? So what is 2 times x?
10x,
I'm sorry, 2 times 5x is 10x, and 2 times 2x is 4x equals 84. 10x plus 4x is 14x is equal to 84. Divide by 14, divide by 14, and x is equal to, how many times will 14 go into 84? 7? Nope, 7 times 4 is 28. Close. 6. 6 times 4 is 24, carry your 2, so you've got 84. So x equals 6. Now let's look back at what the question asked me. When I look back, it says find the length and the width. So if I know that x equals 6, what did I say my length was? 5x. So now that means I've got to multiply 5 times 6 because x is 6. So 5 times 6 is 30 feet. My width, we said, was 2x. So I'm going to have 2 times 6, which is 12 feet. Okay? So they give us these formulas to follow. I want you to get comfortable with going back and looking in the text. If you're not sure what to do, you've got to figure it out. Okay? You've got to look at your example that you've previously had. How can you do that? Okay? So that was 29. We've got 39 as well.
Also have 45 and 47.
Okay. Let's look at 39. All right, so 39, I have 5, huh?
Also have a question on 31. After this,
Okay, let's back up to 31. 31, I'm going to be doing the same similarity. Okay, it says the measures of the angles in a triangle are in the extended ratio of 1 to 4 to 7. Okay. Find the measures of the angles. All right, so let's take a look at this. Let's flip back. I want you to look at example 3. Okay, so if I've got my triangle, what is this one going to be? X. What is this one?
2x.
What is my ratio?
4.
Notice the example gave us 1, 2, 3. So I had x, 2x, 3x. And this one I have x, 4x, 7x. When I add them all together, what do all of my interior angles equal?
12 and 12x.
No, but what do the inside angles of a
Oh.
triangle equal?
180.
180. So I know I'm going to have to add my angles up to equal 180. We said this was 12x equals 180. Divide by 12, divide by 12, and x is equal to 15. So I know one side is going to be 15. So my one side is going to be 15. My 4 is going to be what? What's 4 times 15? 60. And then what's 7 times 15?
105.
There's my 3 sides of my triangle. Okay. So I've got 15 degrees, 60 degrees, 105 degrees. Okay. So there's 31. Let's go back to 39. Okay, 39 gives us a proportion. And I have 5 over x plus 3 is equal to 4 over X. Remember, what do I do here? How do I solve a proportion with an unknown measure?
You multiply it by.
Look back at 459, example 5. Example 5 on 459. What does the cross product property tell me in the green box number 1?
The product of the extremes equal the product of the means.
Okay, I'm multiplying denominator by numerator, denominator by numerator. So what is X plus 3 times 4? That means I'm going to have 4 times X plus 3 equals 5 times X. Okay, so now distribute 4X plus 12 equals 5X. Subtract 12, subtract 12. 4X equals 5X minus 12. Subtract 5X, subtract 5X. Negative X is equal to negative 12. So what does X equal? There you go. Even if it has variables in it or variables plus an operation, you're just going to do it exactly the same way, okay? Product of the means equals the product of the extremes. So that was 39. Let's look at 41. I remember
X equal to negative 12 or positive 12?
X was positive 12 because it was negative X equals negative 12. So positive X is positive 12. Okay, so 41, 7 over 2Z plus 5 is equal to 3 over Z. All right, Easton, tell me what I'm going to do. Based on what we just did in number 39.
Distribute.
Cross multiply.
Yeah, like,
Okay, that way, that way.
So we'll have.
If you want to draw arrows, if it helps you to remember what to do, then you've got 3 times 2Z plus 5 equals what?
7Z.
7Z. Now I distribute, and I have 6Z plus 15 is equal to 7Z. I'm going to subtract 15, subtract 15.
Where did 15 come from?
3 times 5.
Oh,
I had to
okay.
distribute. So I have 6Z equals 7Z minus 15. Subtract 7Z, subtract 7Z. Now I have a negative Z is equal to negative 15. So a positive Z equals a positive 15. So once I distribute, I have 6Z plus 15 equals 7Z. I move my 15 from the left to the right by subtraction. So I'm left with 6Z is equal to 7Z minus 15. Move 7Z from the right to the left by subtracting. So I end up with negative Z equals negative 15. So positive Z equals positive 15. Any questions on that one before I erase it? You good, Clara?
Yeah.
Okay. Number 45. This was yours, right, Alec? Okay. So look at 45. Again, it says the ratio of the width to the length for each rectangle is given. Solve for the variable. So I've got AB is to BC, or AB to BC is 3 to 8. Remember how we talked about our corresponding. So if they said AB first, then 3 goes with AB. Then they said BC, so that's going to be 8. Okay, so just like when we learned about naming polygons, naming things, we want to look at how my letters and my numbers correspond. So whatever they've put first is going to be your first part of your ratio. Whatever they've put second is your second part of your ratio. Okay, and so when I look at my figure, I'll go ahead and draw it real quick, not to scale. And I have A, B, C, D. They said this is X and this is 6. Okay. So notice they said A to B is 6, right? So if my ratio, if I have A to B over B to C is equal to 3/8. Is everybody good with that? What do I know my measure of AB is? 6. What is my measure of B to C? X. So all I've done here is I said AB is 6. BC is X. So I've substituted the values that I know from my figure. So 6/X, I substituted here. What is that equal to? What is 3/8? Is everybody good with that so far? So now what do? Cross multiply. So I have 3x is equal to 48. Divide by 3, and x is equal to 16. Okay, so
same thing on 47. But
Huh?
like you do the same thing on 47.
you do exactly the same thing on 47. Okay.
Okay, I think I get it then.
Okay, good. So I'm glad that you want to get, I want you to try that one on your own using this as your step, and again, this goes along with, which example? I guess in a sense, they had it set up, example 6, when we had the painting and I compared my sides, except for in this situation, I don't have the width of a painting and the width of the photo and the height of the painting and the height of the photo. But basically just know that when I set up my proportion AB to BC, and then I have 3 to 8, that means I can set, remember it said, AB to BC is 3 to 8. And math, what does is mean? Equals. Okay. And remember in our first notes, we said that we can set this up. AB colon BC is the same as AB over BC. 3:8 is the same as 3/8. Okay. So we've got to pay attention to the words they use, the order they put it in, and know that if it's written like this, I convert it to a fraction, and then I can see better to cross multiply. All right, that was 47. And so any other questions from homework? What about the mixed review on page
Yes,
464?
I had 71, 73.
71 and 73. All right, let's look at 71. What does it tell me? My triangles, what are my triangle measure? What are my triangle names? I have
ST.
triangle STU.
Is equal to XWV.
So STU is congruent to triangle
Oh, weird.
XWV. So what angle is angle S congruent to?
I have that one.
But I'm just asking you, looking up here, which one?
X because
Okay, what is T congruent to?
W.
And V or U?
V.
Okay, so now I can see how they line up, so I can see which angles are congruent. So we said that, so this was number 71. I'm looking to see what U is congruent to, and we said that U is congruent to V. Now, that means I have to figure out what V is first. So what was number 69? 95 degrees. So in number 69, you should have found out that V is equal to 95 degrees. Therefore, and you said 71, you can see that U is also 95 degrees. You good with that? They're because those two are congruent. U and V are congruent. And in number 69, you found out that V was 95 degrees. So if V is 95, U is also 95 degrees.
Where did you get a 95 from?
Okay, so look at, or not triangle. So we said that angle S was congruent to angle X. Okay, so let's take a look at that. What is the measure of angle S?
20.
20 degrees. They're both 20 degrees, right? And we said that angle T is congruent to angle W. what was the measure of angle W?
65 degrees.
65 degrees. So what is 65 plus 20?
85.
85. So what is 180 minus 85?
Oh,
95.
Good. So they've given me two of my angles. I had to look at what was congruent, add together what I knew, subtract from 180. And then what other number?
73.
73. All right, so 73 says find the coordinates of the endpoints of each mid-segment shown in red. What is my mid-segment formula for a triangle?
X1 plus X2 divided by 2 and Y1 plus Y2 divided by
Good. X1 plus X2 over 2. Y1 plus Y2 over 2. So we're going to let A be X1. So we'll say A is, what is it, -1, 5. So we need, which two measures do I need to be able to find the length of side AC? Obviously, we need A and C. So we said A is 1, 5, and then C is -2, 1. So that's one side that we've got to find the halfway point of. And then we also need to find the halfway point of A to B, which is 3, 1. Okay, so here for this one, I'm going to have -1 plus -2 over 2, and then 5 plus 1 over 2. So -1 plus -2 is -3 over 2, and then I have 6 over 2. So I'm going to have -1.5, 3. And then for my next one, I've got -1 plus 3 over 2 and 5 plus 1 over 2. So -1 plus 3 is 2 over 2. 5 plus 1 is 6 over 2. 2 over 2 is 1. 6 over 2 is 3. So my midpoint is going to be -1, 3, 1/2, -1 and 1/2, 3, and 1, 3. Okay, so remember, these are going to be things that you have to, and notice if you look right above, look in your directions. It says review 5-4. Okay, so it tells you where to go back and look. If you can't remember the mid segment of a triangle, then you can go back and it tells you which lesson to flip back to. Okay, I want you to get comfortable with going back in your text to be able to find what you're looking for. I don't want you just to go, ooh, I don't know how to do that, so I don't know how to do that. Go back and figure it out. Okay, any other questions from homework? All righty, now let's go ahead and take a look at 8.2. Problem solving in geometry with proportions. Okay, so we're starting on 8.2, page 465. And it says in lesson 8.1, you studied the reciprocal property and the cross product property. Two more properties of proportions, which are especially useful in geometry, are given below. You can use the cross product property and the reciprocal property to help prove these properties in exercises 36 and 37. So they're telling us right there when we get to 36 and 37, then we may need to be looking back at properties that we already know, how they apply to the properties that we do know. So notice here, we looked at properties 1 and 2 in 8.1. Now we're at 3 and 4. So the first one says, property 3 says, if A over B, that's your first blank for 8.2. If A over B is equal to C over D, then A over C is equal to B over D. What did they do there? They said if A over B equals C over D, then A over C is equal to B over D. So notice they said that I can set it up like this, or I can compare the things that are in my numerator as a fraction or as a ratio, and I can put my denominators as another ratio. Okay? So, but the main thing is I could not take a numerator and a denominator and put them. Okay? So I can either start out with A to B is to C to D, or I can take AC and put it as a ratio and BD as my second ratio to make my proportion. Okay, Easton?
Just make sure, you know, if I'm not writing, just
Cool.
Just make sure.
Okay, very good. All right, so number 4 says if A over B equals C over D, then A plus B over B is equal to C plus D over D. Okay, so if A over B equals C over D, then A plus B over B is equal to C plus D over D. So let's take a look at example 1. Using properties of proportions. It says tell whether each statement is true. If P over 6 is equal to R over 10, then P over R is equal to 3 over 5. What did they do there? They simplified, yeah. So they said, hey, 6 over 10 reduces to what?
3 over 5.
3 over 5. So basically they started out and said P over 6 is equal to R over 10. Then P over R would be 6 over 10, but then P over R is equal to 3 over 5. Okay, so what they did is they started out with my original proportion, then they used our third property that we just talked about, where I put numerator over numerator is equal to denominator over denominator, but then they reduced 6 over 10. So is this a true statement? Yes.
Yes.
Good. Let's look at letter B. It says if A over C is equal to C over 4,
A over 3.
then A over 3, oh, I was going to say something's wrong. A over 3 is equal to C over 4, then A plus 3 over 3 is equal to C plus 3 over 4. Is this a true statement? Look at property number 4. Property number 4 says if A over B equals
Yes.
C over D, then A plus B, if this is B, A plus B over B is equal to C plus D. What is this right here? Is that D? No. So if I'm adding, these two numbers have to match. So these have to be the same and these have to be the same. So this is not a true statement because I'm adding B here and I cannot have C plus B over D. That is not correct. Okay, so that is not true. Let's go ahead and look at example 2 on page 466. Okay, so on 466, example 2 says using properties of proportions. In the diagram, A over B, let's see, AB over BD is equal to AC over CE. Okay, and we've got our figure. Let me go ahead and just draw it. Again, not to scale. A, B, C, D, E, 16x. They said this whole thing is 30, and this down here is 10. Okay. So what I want to do is, given this proportion, I want to plug in the numbers or the measurements that I know. So what is the measure of AB? What is my measure of segment AB?
Oh, 16x.
16. Nope, not 16x, just AB is right here. Okay, so I have 16 over, what is BD? X is equal to, what is AC?
30.
How can I figure out? No, A to E is 30.
20.
So AC is 20 over CE, which is 10. So I'm using my proportion, what they've told me. I'm taking the measures of what they've given me. Now I've got to solve for my unknown. How am I going to solve for X?
Cross multiply.
Cross multiply. So what's 20 times X?
20x equals 160. X equals 8.
Divide by 20, divide by 20. So X is equal to 8. So now we can see that right here, this side, this is going to be 8. So 16 and 8 is 24. So the length of this side would be 24 if I needed to know that. Okay. Our next thing says the geometric mean. Let's think about what does that mean? What is a mean? What's another word for mean? Average. Good. So when I talk about a mean, I need to know that that's talking about an average. Okay. So the geometric mean of two positive numbers A and B is the positive number X, such that A over X is equal to X over B. If you solve this proportion for X, you find that X is equal to the square root of A times B, which is a positive number. Let's dissect that. Okay. So our next bullet point in 8.2, it says the blank of two positive numbers A and B. So this is the geometric mean. The geometric mean of two positive numbers A and B is the positive number X, such that A over X is equal to X over B. If you solve this proportion for X, you find that X is equal to the square root of A times B. So let's look at that for just a minute. Notice that what they told us is that if I have A over X is equal to X over B. When I cross multiply, what is X times X? Not 2X, that's X plus X.
X squared.
X squared. Remember, when I multiply variables, it's going to be squared, cubed, whatever. But if I add them, that's where I increase my coefficient. Okay. So X squared is equal to AB, right?
Mm-hmm.
So how could I solve for X?
Divide by X.
I can't divide by X. What is the opposite of a square? What is the opposite of addition? What is the opposite of multiplication?
Division.
What is the opposite of an exponent or a square? Okay, so if I want, remember the square root of X squared is the same as X times X. And think back to Algebra 1 when we talked about when I simplify radicals and I have to look at my buddies. Okay, those of you that didn't have me, I had a little thing where I said, okay, this is broken down into buddies. And Mama said that the buddies cannot go outside unless they have whatever my index is. I have to have that number of things in the house to go outside. Right now, I have 2 X's, so that can come out as a group of X because my understood index is 2. I've got 2 buddies together, so they can go outside as 1 X. But right now, I cannot break down, AB, because I don't know what they are. If it was AA, then A could come out. If it was BB, B could come out. But it's AB, so I don't have 2 like buddies. Okay, so that's what this is saying, that if I have A over X is equal to X over B, when I use my cross multiplication property, I end up with X squared is equal to A times B. To be able to solve for X, I have to take the square root of both sides. I can take the square root of X squared, but I cannot take the square root of AB. It's just left there. So it says, for example, the geometric mean of 8 and 18 is 12 because 8 over 12 is equal to 12 over 18. So let's think about this for a minute. They said the geometric mean, so I'm going to say GM is geometric of 8 and 18. So notice when they said 8 and 18, 8 is A, 18 is B. So when I use this formula here, A over X is equal to X over B, then I translate that to 8, and they said X is 12. Did they tell me that in the problem? Yes. Okay, they said X is 12, so I plug in 12, both places I see X. What is 12 times 12?
144.
144. And 8 times 18 is also 144. Okay, but if I did not know that, let's take a look at example 3. Using the geometric mean. I'm going to keep this right here. What I'm going to do is I'm going to go ahead and start writing example 3 on the board. The bell is about to ring for our break. And so as soon as the bell rings, y'all can take a break, and I'll have this on the board, and we will pick up with example 3 when we get back from break.
Low-key, it'd be fun to push. See it like swirling in a- It'd be like, it'd be in like a tsunami, like,
Because they're a part of this paper. When they say
I see you swirl.
All right, you can take a break. I'm a little. Okay, I might see. That's gonna be better because I'd rather work on these really white squares over here so it'd be easier to see. I need to order, I was gonna see how much it was just to get a big old piece of vinyl. Well, what happens is type of material,
I found that what my mom used to do when she homeschooled us, or like when she used to homeschool us a long time ago, you can get like a sheet of like, what's it called? It's like this material that you can get at Lowe's really cheap.
yeah, I was gonna say, I think just vinyl, like sticky vinyl, I think is what this is.
Okay.
And you can order bigger pieces of it, but that's what, over time, just the surface of this has broken down with
Yeah.
it being cleaned so many times and with so many different things and whatever, it just, the surface of it
Yeah.
disintegrates, and so it just holds color better. So, because I'm trying to think of how many years we've been in this building now.
Quite a while.
It's been several years, and so I don't think it was like one of the top of the line. I think, I could be totally wrong.
Yeah.
I think this is actually what's called, oh gosh, what's it called? It's something that you can get at Lowe's. It's like a, I can't even remember what it's actually called, but whatever it is, shower board. It's called shower board. Whereas like real dry erase boards are super expensive
Right.
because they have a better coating on them. And so I think this is just shower board, so it doesn't have as good of a coating on it.
Yeah, that's what we used in our
Yeah.
schoolroom.
So, but I gotta try to remember. I was the other day when I was looking on Amazon, and I totally forgot to look again to see if I could find a bigger sheet of this to make our board a little more white. Alrighty, so what we're gonna do is we have started out and we said we're doing geometric mean, and we know that A over X is equal to X over B. So I went ahead and wrote out our steps for geometric mean up here. But in the example they've given us, I have two different types of paper, okay? And so there's all kinds of different sizes of paper, and each size of paper has a different letter naming system. So it tells us in this, international standard paper sizes are commonly used all over the world. The various sizes have the same width to length ratios. Two sizes of paper are shown called A4 and A3. The distance labeled X is the geometric mean of 210 millimeters and 420 millimeters. So they've told us that I've got one side is one piece of paper is 210 millimeters. The other is 420 millimeters, and we find the value of X. So A in this situation is 210. B is 420. Okay. We're not talking about time. Come on now. All right, so we got A and B. So we have 210 over X. Remember, my X values are always right here. The denominator of the first one, the numerator of the second one. So those are going to stay the same, right? And I plug in 210 for A, 420 for B. So I'm going to have X squared is equal to 210 times 420. So when I look at that, I'm going to cheat and look at my book. All right, and actually they say the easiest way to do this is to not even multiply them together. So I want to go ahead and say X is equal to the square root of 210 times 420. This is the point where we have to stop and break down prime factors and all that good stuff. Now, in algebra, we started tiny and went up big. What we want to start doing is looking at, especially when I have larger numbers, I want to look at how I can break them down more simply, okay? So if we look at 210 and 420, what do we notice about those two numbers? Do it.
They're both divisible by 10.
They are both divisible by 10, but look at the relationship of the two. 210 is half of 420, right? So really, I've got X is equal to 210 times 210 times 2, right? Because 420 is going to be 2 times 210. So remember how we talked about buddies? What do I have that are buddies now?
210 and 210.
210 and 210. I've got two of them under here. So they can come out, but what has to stay under the radical sign? The 2. Okay, so when I simplify those, I've got 210 is able to come out because I have 2 of them under the radical. My understood index here is a 2. What if my index was a 3? How many 210s would I have to have under the radical for one group to come out?
1.
If this was a 3, if my index was 3, I'd have to have 210 times 210 times 210 to come out as one group. Remember, if an index is 3, I have to have 3 of something under the radical sign. When I have no number here, I understand it to be 2, taking the square root. So I have to have 2 of them under the radical sign. Now, one of the things I will tell you is I'm totally fine at this point where y'all are. If y'all want to use a calculator to find square roots, then you don't even have to simplify. You just put in and calculate the square root of whatever 210 times 420 is, find the square root, okay? So it's up to you. All righty. Now, notice it says underneath it, it says the geometric mean of 210 and 420 is 210 times the square root of 2, or about 297. So the distance labeled X in the diagram is about 297 millimeters. So let's stop there for a minute. First of all, let's go ahead and, let me see something real quick.
Oh yeah, are we not, is she not on Zoom today?
Mhm.
Oh, we're still doing the thing. Cause usually we have the projector. I'm saying.
Right, I just went ahead and I figured it was easier than turning out the lights and stuff like that. I'm using this to just so she can see the board. Now it's backwards, but yeah. All right, so what I want you to do for just a minute, if you have a calculator, get it out. I want you to look at this right here. If you have a calculator, whether it's a calculator, if it's on your phone, now, all these boys and y'all's pink phone cases, my goodness. Okay, so look at this real quick. What operation is this right here? If I have 210 times the square root of 2, what operation is that? I just said if I have 210 times the square root of 2, what operation is that? Multiplication. So think about if they said that the geometric mean of 210 and 420 is 210 times the square root of 2, or about 297. How in the whole wide world did they get that number 297? First of all, I want you to calculate it on your calculator. Hit the square root of 2 equals. Okay, so if you turn it sideways, you should end up with a scientific calculator when you get your calculator app on. Tap the square root symbol, 2 equals. Notice the square root of 2 is equal to 1.41421356624. Something like that, okay? What does that mean I have to do with this number and 210?
Simplify it.
Multiply it, because it's this times this. If this equals this, then I've got 210 plus, I'm sorry, not plus, times 1.41421356624. So when you've got that on your calculator, hit times 210. And you end up with 296.984848 ... Okay, so I'm going to round that to 297. Good, and if I could write the things that I say, that would be amazing. Brain and hand are not connected today. 297. So that's how they got that number. Okay, so again, if you were just using your calculator, now do the same thing. First of all, I want you to multiply 210 times 420. 210 times 420 equals 88,200. Now I want you to find the square root of 88,200. Lo and behold, it matches that number. Okay, so you can either start here, multiply these two together and find the square root, and you're going to end up there, or you can simplify and leave it as a simplified radical. It is totally up to you how you do that, okay? If you want to use a calculator, you are welcome to use a calculator, simplify radicals, okay? Questions about that? Just remember, don't forget what our basics are. When I have 210 times the square root of 2, I multiply to find my solution. I'm not adding them, I'm multiplying, okay? All right, let's look at goal 2. It says, in general, this is on page 467. In general, when solving word problems that involve proportions, there is more than one correct way to set up the proportion. The main thing that we have to make sure of, though, is when I'm setting up my proportion, that I have consistent, that my numerators are consistent with my other numerator, denominators are consistent with the other denominator. Okay, so now I'm going to move over to these nice little clean white squares. It'll be easier to see. Okay, so example 4, we are solving a proportion that says model building. A scale model of the Titanic is 107.5 inches long and 11.25 inches wide. The Titanic itself was 882.75 feet long. How wide was it? So in this situation, I've got 2 ways I can set this up. So I can look and say the width of the model compared to the width of the actual is equal to the length of the model over the length of the actual. Okay, so notice my numerators both, my denominators both have actual. Or I could go ahead and say, I want to have the width of the model over the length of the model. So what would have to be in my numerator over here? If I put the width of my model over my length of the model, what's going to go in my numerator here?
Length over width.
Length what?
Outside. Wait.
The length of what?
So I can't.
Okay. We're talking about a model and an actual. Okay, those are 2 things that I'm comparing here. We just said I'm doing width of model over width of actual is equal to length of model over actual.
Actual.
Now here, what is in my numerator? Width of,
Model.
so over here has to be the length of,
Actual.
no, it has to be the same. The length of the model over the, I'm sorry, I wrote the wrong, no, I'm sorry, you're right. I'm backwards. I was going back up here. So length of actual over, no, good night. This is where I start, not length. Reset, back it up. Width of model over length of model. So over here needs to be the width of what?
Actual.
Actual over length of
Actual.
actual. So notice here, my common things, I have width and width. Over here, I have length and length. I just have to make sure that I've got model in both of my numerators, actual in both of my denominators. Over here, I've got model and model. Over here, I have actual and actual. So I need to make sure I have width and width, length and length. So do you understand about setting them up where they correspond? Okay. Do you remember when we talked about, let's see. All right, see if y'all can remember this.
Yes.
Yes.
Okay.
Oh,
Now look at
Ma.
angle 2 and angle 6. What are those called?
Corresponding.
Corresponding angles, right? Because of their position, they were corresponding. That's what I'm having to pay attention here with my proportions. I have to have corresponding information, okay? So when I think of corresponding, they've got to be linked together by position. So here I can either have width over width is equal to length over length, but what has to correspond has to be models in the numerator, actuals in the denominator. Or I can set it up with width and length, but I have to have width and width here and model and actual, or length and length with model and actual. Okay, so I can set it up a couple of different ways. What I could not do is compare my width of my model here, my width of my actual, and then put actual in the numerator and model in the denominator. I can't flip flop them. Does that make sense? Same thing here. I couldn't flip flop here. I couldn't have the width here and then length up here. They have to correspond. All right. So now, again, so what they've done is they actually flipped it also, and you could put actual up here. But if I had actual here, what has to be here?
Wait.
What would have to go here?
Actually.
Good. And then here, I wanted to have length of model over width of model equals length of actual over width of actual. So in this situation, I actually have 4 different ways I could set up this one problem. What I have to make sure is I've got the corresponding information. Okay, so I have options, but they have to correspond to make sure that they're in the right placement. So in the example, they said I've got width of the actual over the width of the model equals the length of the actual over the length of the model. So they said the width of the Titanic is X. We do not know that. That's what we're trying to solve for. So typically when your question says solve for or find the length, then I know that that's what, or it says how wide was it? So I'm solving for width. So I know that's going to be my variable. So I'm going to end up with X over 11.25 because I've got width of actual over width of model is equal to the length of the actual, which is 882.75 over 107.5. So they said width of actual over width of model is equal to length of actual over length of model. So I plug in what I know. I'm solving for the width of the actual. I know the width of the model is 11.25. I know the length of the actual is 882.75. And I know that the length of the model is 107.5. Cross multiply. I end up with 107.5x is equal to 882.75 times 11.25. So you can see here they have multiplied and I end up with x is approximately 92.4. Again, you can use your calculator. So 107.5x is equal to, and I multiply 882.75 times 11.25. That is a big number. It's going to be 9,930.9375. So then I divide by 107.5, divide by 107.5. 9,930.9375 divided by 7.5. It ends up being 92.3808 ... So rounding to the nearest tenth, it's approximately 92.4. Okay. All right. So let's go ahead and take a look. If you haven't finished with your bullet points when writing proportion with unlike units, let's see where that was. Look at the very bottom of 467. It says, notice that the proportion in example 4 contains measurements that are not in the same units. When writing a proportion with unlike units, the numerator should have the same units and the denominator should have the same units. So when writing proportions with unlike units, the numerators should have the same units and the denominators should have the same units. So that's going to be when you're setting these up and you're having to pick, okay, I've got 4 options here. I need to make sure that I've got units corresponding what they've just told us. Numerators have units that correspond, denominators have units that correspond, okay? So our homework in this section for 8.2, we have pages 468 through 470, numbers 9 through 27 odds, and number 33. Then we have mixed review, page 471, 47 through 55 odds. Let's go ahead and turn to 8.3, similar polygons.
We can have the guided practice.
Pardon?
Can we do the guided practice?
Yeah, we can do the guided practice. Let's go ahead and take a look at that real quick. If X is the geometric mean of 2 positive numbers A and B, write a proportion that relates A to B, A, B, and X. What was our formula for geometric mean? A over equals X over B. Good. Number 2, if X over 4 equals Y over 5, then X plus 4 over 4 is equal to what over 5? Y plus 5. Good, because remember we said that A plus B over B is equal to C plus D over D. So I've got to make sure that those correspond. So for number 2, the missing part is Y plus 5. Look at number 3. If B over 6 is equal to C over 2, okay, so I've got B over 6 is equal to C over 2, then B over C is equal to what? Now notice here, if I've got B over 6 is equal to C over 2, I have taken B and put it in my numerator. C is now in my denominator. So what needs to be in my numerator over here? You're right, but we're not there yet. 6 over 2, which simplifies to what?
3.
Now, question. What was our rule about proportions? Okay, remember we need 2 parts. So, but even my book says it could be 3. So really you could have 6 over 2. You could have that as 3 over 1 or 3. Okay. I won't count off. Number 4, decide whether the statement is true or false. If R over S is equal to 6 over 15, then 15 over S is equal to 6 over R.
True.
Good, true. Because notice when I multiply in the first one, R over S equals 6 over 15. What do I multiply S by? If I have R over S equals 6 over 15.
Oh, 6.
Then I'm going to have 6S is equal to 15R, right? Notice if I flip-flop that, I have 15 over S is equal to 6 over R. When I cross multiply, I still have 6S is equal to 15R. So they true statements. When I cross multiply, I've still got the same products. If they do not end up being the same products, then that's when you say it's a false statement. Look at number 5. It says find the geometric mean of 3 and 12. So geometric mean, we already said, was A over X is equal to X over B. What is A going to be?
3.
Good. So I have 3 over X is equal to X over 12. So X times X is X squared. 3 times 12 is 36. So what does X equal?
X is equal to 6.
6, because it's square root, square root. Good. And then number 6 in the diagram, AB over BC is equal to AD over DE. Substitute the known values into the proportion and solve for DE. Let's start right here. So we said that AB over BC is equal to AD over DE. So what do I know the measure of AB is?
2.
2. What is the measure of BC?
3.
What is the measure of AD?
6.
And what is the measure of DE? Do we know? I don't know what it is, and that's gonna be my variable. Whatever I don't know is my variable. So I have 2x is equal to 18, so x is equal to 9. So I know that whole side is 9. Not the whole side. I know DE is 9. So what is my whole side? Look at your picture. If we said that DE
20.
is 9, what is AD? AD is 6. So what's 9 plus 6? 15. So the whole measurement of A to E is going to be 15. Number 7, dealing with the flag. The official height to width ratio of the United States flag is 1 to 1.9. If the United States flag is 6 feet high, how wide is it? So the first thing I'm going to do is I'm going to start with the ratio given me. I know that it is 1 over 1.9. So I've got length and width. Now it says if it's 6 feet high, how wide is it? Okay, so notice in the problem, they said it is 1 to 1.9. Okay, then they gave me what measurement first? If it's 6 feet high, then what is the other? So this is how I look. The order that they have told me is the order that I set up my ratio. So they said 1 to 1.9. So 6 is up here, and I'm solving for x. So I have x is equal to 6 times 1.9, and that's going to be 11.4 feet. Okay, so pay attention to the order they give you the information in, and that's how you figure out what it corresponds to. That's how you figure out if I set up 1 over 1.9, I got to set 6 over x. Okay, and then finally, number 8, the blue portion of the United States flag is called the Union. What is the ratio of the height of the Union to the height of the flag? So think about this for a minute, okay? If we're talking about the height of the Union to the height of the flag. So when I set up my proportion, I've got width of Union to width of flag is equal to length of Union over length of flag. Okay, so I'm going to plug in what I know. What do I know? Let's see, I'm finding what is the ratio of the height of the Union to the height of the flag? So I'm trying to find, well, I did length and width instead of length and height. Erase this up here so we can see better. Height of the Union to the height of the flag. So what did we say our regular flag is 1 to 1.9? And what does the 1 tell me? It said it was height to width, right? And so so if I know my actual flag is 6 to 11.4, height of the Union to the height of the flag. So I've got to have height of the flag. So I've got height. All right, give me a minute on this one. Why am I drawing a blank? It ends up being 7 over 13. The height of the flag. All right, I'm going to work on number 8 and get back to y'all tomorrow on that one. When class ends, I don't want to spend time that we have left trying to figure that one out. So I'm gonna get back to y'all on number 8 and figure that one out. So our homework, let's go ahead and take a look at it. 9 through 12, logical reasoning. It says if this, then this. You're just gonna plug in and solve, okay? Now notice in numbers 9 and 11, you're just writing the other you're writing the other ratio. You're not solving anything. You're just writing the ratio. Numbers 13 and 15, you're deciding true or false. Numbers 17, 19, and 21, geometric mean. So you're going to need to know that A over X is equal to X over B. Plug in what you know and solve. Find the geometric mean. And then we've got on page 469, given us parts of our triangle measurements, and we have to find segments on 23, 25, and 27. Huh?
What are we doing on this?
Okay, well, if you will, hold on and let me get there. Then turn the page 470, I've got number 33. Number 33 says coordinate geometry. I have my points. I have 3 points that they've given me, and they're collinear, so find the value of X by solving the proportion below. They've given us the proportion, and I've got to solve for X. Okay, so what is 1 minus a negative 1?
2.
And what is 1 minus a negative 4? 5. And what is 5 minus 1? So basically, I'm going to simplify my numbers first, then cross multiply to solve for X. That's number 33. Now, mixed review on 471, we have 47 through 55 odds. Finding area is my first two that you will have, numbers 47 and 49, area, okay? And then the numbers 51, 53, and 55, find angle measures. So you can see they've given you 2 parallel lines. They've told me what sides are congruent, and I'm going to solve for angle measures, okay? Remember, it tells you look back to review if you cannot remember what to do. All righty, 8.3, similar polygons. So turn your notes over on the next page, on the back page. Okay. When there is a correspondence between 2 polygons such that their corresponding angles are congruent and the length of corresponding sides are proportional, the 2 polygons are called similar polygons. Why are they not congruent? They're not the same size. Okay, notice when we look at these pictures, I have got shapes that look the same. I've got angle measures that are congruent, but my side lengths are not congruent. So these are not congruent polygons. These are similar. Similar means they're going to have the same shape, but they have different sizes. Okay. So similar polygons are 2 polygons that have corresponding congruent angles and corresponding proportional sides. So my sides are proportional, the angles are congruent. Yes. Yes. So now the next thing says draw 2 similar polygons showing congruent angles and proportions for sides. So you're drawing that example in the book on page 473. Draw that, put your corresponding angles, and set up A over B equals E over F. I'm sorry, AB over EF equals BC over FG, which equals CD to GH, which equals DA to HE. I want you to draw that out so you've got that image in your mind. You're drawing the exact same figure. One is larger than the other. Does not obviously have to be perfect, because your congruence marks are going to help you know. So notice when you've written down those proportions right there, and we have AB over EF is equal to BFG is equal to CD over GH equals DA over HE. This is setting up the proportions to say that all of my sides are proportional. So when I'm looking at this, remember when I do proportions, I can only have 2 equal ratios, okay? So I can only pick 2 of these to solve a proportion. So I could either start with my first 2 and I could solve for an unknown there. I could compare my first and my last together. All of these are proportional, so it's telling me that they have the same proportions. So I can do 2 at a time. So that's one of the things that you need to know is that if you see a whole string of proportions like this, you can't do all of them at the same time. I have to go step by step. I have to compare 2 pieces. I have to compare an unknown with something that's a known to be able to solve, and then use that one to compare the others, okay? So it says in the diagram, ABCD is similar to EFGH. So again, remember that A corresponds to E, B corresponds to F, C corresponds to G, D corresponds to H. And so it says that we can use the symbol of similarity, which is just that little wavy line, okay? So my symbol of similarity, what are we used to seeing that little wavy line with? Congruence, yeah. So, be great if I,
It's done.
So when I have that, that means similar to. So usually when I have my congruence, that means it is similar and equal. That's why congruence has both, because they are similar and equal. Same size, same shape. Okay, this one, I just have same shape, but I don't have the same size. So that's why it's only the little wavy line to show similarity. Okay, so Easton, if you have not drawn the picture from 473, that's what we did while you were gone. All right, let's look at example 1. I have 2 pentagons, JMN and STUVW are similar. List all of the pairs congruent congruent angles. Write the ratios of the corresponding sides in a statement of proportionality. So you can see that it says because JKLMN is similar to STUVW, we know that angle J is congruent to angle S, angle is congruent to angle T, angle L to angle U, angle M is congruent to angle V, and angle N is congruent to angle W. So we've listed all of our angles of congruence. Now our statement of proportionality is going to show that side JK over ST is equal to KL over TU. I want you to stop for a minute and look at those. With your finger, trace over JK. Okay, so look at JK and that over ST. So notice ST, those are going to be my corresponding sides. So JK ST is equal to, now do KL with your finger over TU. So notice now I've got KL in my big figure over TU in my small figure. So that's how we're setting up these corresponding sides. I won't make you trace over LMUV, MN over VW, and NJ over WS. But I know that my sides are proportional, so I can set them up and I can compare the side of figure 1 to the side of figure 2 is equal to another side of figure 1 that corresponds to figure 2, which is equal to my third side of figure 1 that corresponds to figure 2, and so on. Look at example 2, comparing similar polygons. Decide whether the figures are similar. If they are similar, write a similarity statement. So let's look at our figures. I have WXYZ and PQRS. Which angle corresponds with angle X? Q. U.
P.
What corresponds with Z? And with Y? Okay. Now, what is our measure of XY?
Wait, oh,
What is the length of XY?
15.
Look at XY. Look at the figures.
6.
6. What is the length of QR?
4.
4. So if I was comparing XY over QR, we can see our proportion is 6:4. Okay, what would that reduce to? 3/2. Okay, so when I'm setting up my proportions, again, in example 1, we look to see which sides correspond with what. So when I'm setting up my proportions, I have my corresponding side measures over the measure of the corresponding figure side. So WX over PQ is equal to 15/10. Does everybody see where WX is 15? Do you see where PQ is 10? Notice they reduce to 3/2. Look at XY over QR. That's what we just looked at. And we said XY is 6 and QR is 4. 6/4 reduces to 3/2. YZ is equal to 9. RS is equal to 6. What does that reduce to?
3/2.
3/2. ZW over SP is 12/8, which reduces to 3/2. So if each of these all reduce to 3/2, then my sides are proportional. Okay, so my sides are proportional, my angles are congruent, so these are similar figures. Everybody good with that? Turn the page to 474. Let's look at Goal 2, using similar polygons in real life, comparing photographic enlargements. We have a poster design. It says you've been asked to create a poster to advertise a field trip to see the Liberty Bell. You have a 3x5 or 3.5 inch by 5 inch photo that you want to enlarge. You want the enlargement to be 16 inches wide. How long will it be? So again, remember I'm doing, do what?
22.9.
Okay, but let's look at how we get there. Okay, so first of all, it says it's 3.5 by 5. Okay, so what is my width?
Width.
The width is
16
3.5. The height is 5 of my original photo. How big do I want it to be?
16 inches wide.
16 inches. What does it say?
Wide.
Okay, it's 16 inches wide.
Wide.
Okay, so we're trying to find the height. So I'm going to have 3.5x is equal to 16 times 5. What is 16 times 5? 80. Divide by 3.5. Divide by 3.5. 80 divided by 3.5 is?
22.9 inches. Just guess.
22.85,
I was right.
which is approximately 22.9. Now, how is what I did different than the book?
You didn't, magic.
No, no magic in math.
You didn't multiply both sides by 3.5 inches.
What did I?
Biology. Width and height.
Width and height. How did they set it up in the book? They did length on top and then width on the bottom. So they just flip-flopped it. Remember, there's usually going to be 4 different ways you can set up a proportion. But notice that I flip-flopped mine. What I wanted you to see is that it's not magic on how you get the right answer. You just have to make sure you've got corresponding information with corresponding information. So what I made sure of here is if I said width is in the numerator, then in the next one, it has to be width, and the other one, it has to be width. So height has to be through the bottom, through the denominator. So just make sure, however you set it up, that you set up corresponding information. Now it says if 2 polygons are similar, then the ratio of the lengths of 2 corresponding sides is called the scale factor. So you've got scale factor there. In example 2 on the previous page, the common ratio of 3 to 2 is the scale factor of WXYZ to PQRS. So look at your notes. You should have filled out the first bullet point with sides, angles and sides, and then drew your pictures and your corresponding sides. Then your symbol to indicate similarity, you should have your little wavy line. If two polygons are similar, then the ratio of the lengths of the two corresponding sides is called the scale factor. Now, in example 4, using similar polygons, the rectangular patio around the pool is similar to the pool as shown. Calculate the scale factor of the patio to the pool and find the ratio of their perimeters. First of all, what do I see the length of my patio is? What is the length of my patio?
48 inches,
48 inches.
Oh,
What is the length of my pool?
16.
So length of patio to length of pool is equal to, what is the height of my patio?
24.
And the height of my pool?
32.
Okay, so notice I've said length of patio to length of pool, height of patio to height of pool, okay? And so when I look at that, 24 over 32 reduces to what? What are both 24 and 32 divisible by?
8.
8. What is 8? What is 24 divided by 8?
Pool.
What is 24 divided by 8? What's 32 divided by 8? So that ends up with a ratio of 3 to 4. Okay? No, it does not.
If he told you wrong, you
I
don't-
had it.
Oh, who told me 24 to 32? It's 24 to, oh, it was 48 to 32. And then 24 to 16. So then 24 over 16 are both divisible by 4. So end up with 6 over 4, which is 3 over 2. Okay? So, all right. So your homework is going to be just 8-2.
Yeah.
So we will pick back up on 475 with theorem 8-1. So we will go over any questions that you have tomorrow if you're able to get the homework done. If not, then we can answer questions on that next Wednesday as well. But we'll pick up with page 475 at the top, so you know that for your first part of homework tomorrow night is going to be 475. So if you have questions, please be sure to let me know. Tomorrow, the plan will be to finish 8-3, move on to 8-4, and see what we can get in 8-5. Okay, so if you start your homework tonight, you're going to have less to catch up on for next Wednesday. If you put it off, then you're going to have 8-2, 8-3, 8-4, and 8-5 due by next Wednesday.
Don't be like
Okay.
me. Don't
So don't be a Lucas. Don't put it off. Okay. Keely, if you have any questions, be sure to let me know. If we need to set up any individual time, I'm happy to do that. And I hope you feel better. And we'll see you soon, okay? Bye, hon.
Yes, ma'am. Thank you so much.
You're welcome, hon. See you soon.
We gotta wait. We gotta check it. We gotta check it.
We'll send me still there.